Hello, everyone. Today, we will present to everyone a solution for this challenge. The solution we propose is called LoRa Fine-Tuning for VizWiz Grand Challenge. Our team named SLCV comes from Shopline AI Research. The team members are composed of Bao Jun Li, Jiemian Huang, and Tao Liu. In this competition, we challenged 3 tracks as shown in the video. In order to reduce the difficulty of our work during training the model, we decided to use a unified tuning architecture to solve these 3-track tasks. After completing the baselines of some models, such as Blip2, Lava, and Cogagent, we analyzed some related bad cases and found that the Cogagent model is better than other models. We suspect that the Cogagent model has high resolution and low resolution image encoders, making it easier to understand more details with smaller objects in the image than models with one image encoder. Furthermore, we found the DeepSeek VL model based on this feature of the discovered multi-image encoder. We conducted comparative experiments between DeepSeek VL model and the other models with only a single image encoder, and a comparative experiment between DeepSeek VL model and the Cogagent model. Comparative experiments show that DeepSeek VL and Cogagent models that use 2 image encoders have similar effects, and significantly better than the other models that use a single image encoder. As shown in the video, through a series of ablation experiments, we finally selected appropriate high-resolution parameters and low-resolution parameters for the DeepSeek VL and Cogagent models. It is extremely difficult to train large visual language models from scratch or through general fine-tuning methods. Fortunately, the tuning method of the LoRa series has been proposed. We chose LoRa Plus as the tuning method for training models, because LoRa Plus sets different learning rates for low-rank matrix A and low-rank matrix B respectively. It can not only slightly improve the effect of the model, but also speed up the training of the model. Through experiments, we found that the 2 model effects of DeepSeek VL and Cogagent can achieve optimal results when the ratio of the learning rates of low-rank matrix B and low-rank matrix A is equal to 16. We also experimentally selected the model low-rank values of DeepSeek VL and Cogagent to be 256 and 8 respectively. In the track of VQA Task 1, we only used data with answer_confidence as yes to train the models, and used LoRa Plus tuning models for only 1 epoch. In the test standard phase, we ensembled the results of 3 models and finally obtained an overall score of 78.91. In the track of VQA Task 2, the tuning method is the same as that of Task 1. But the answer we set is a probability string, and this probability is calculated according to the formula shown in the video. In the test standard phase, we assembled 6 models and obtained an AP score of 89.74. In the VQA answer therapy track, we set probe to 1 for data whose binary underscore label is single and 0 otherwise, and finally stringify the probability as the answer. And in the test standard phase, it achieved an overall F1 score of 85.64. In this competition, we not only used some innovative ideas from predecessors such as multiple image encoders and LoRa Plus, but also used some of our own tricks such as stringifying probability values. We feel that these innovations also indicate the direction of future development. VQA type tasks still face some open challenges. There are difficult number type questions like the text VQA challenge, and other uncertainty type questions that still need to be overcome. That's all. Thank you.